Hi my dear friends, welcome to Venus EduTech. In this video, we are going to discuss the solution of the homework questions in our textbook exercise 1.2, right? So you solved it all. Hope you all got the correct answers. Let's check it. The first question is, express each number as a product of its prime factors. The first question is 140. How we can write 140? By prime factorization. In stepwise we can write by. So you have to write like this when it is asked in the examination, right? So by prime factorization we get, what we get? 140 is equal to, and do it like this, 270, 235, 5, 7, right? So 2 into 2 into 5 into 7, right? Which can be written as 2 square into 5 into 7. Next question, 156, right? This is first one. Then what about 156, which is equal to, this is not working. 156 can be written as, by prime factorization we get 156 is equal to 39, 13, 3. Here we can write it as 13, right? So how we can write 2 into 2 into 3 into 13, which is equal to 2 square into 3 into 13. Got it? Then the third one, 3825, right? So how we can write 3825? By prime factorization we get, when it is divided by 3, like this, again with the 3, like this, then with the 5, like this, again with 5, like this, right? So how we can write? How we can write 3 into 3 into 5 into 5 into 17, which is equal to 3 square into 5 square into 17. Got it? Then what about fourth one, 5005. 5005. When it is divided by 5, it is 1. Then when it is divided with 11, is it possible? Yes. 999. Then 11, 1, right? Then with 7, 13, right? So how we can write it as 5 into 7 into 11 into 13. Got it? Then what about the other one? 7429. 7429. It is not divisible by 3 as well as 7. So go for 17. Is it possible? 17 into 5, it is 85. So 17 into 4, 28 to 1, 68. So 4, it is 68. Then 62. 62 means 3, 51. Then 11, 119. 17 into 7, yeah, 437. Then with 19, is it possible? We can check it. 19 into 238, 19 into 3, 57. So 238, then 57, yes, 23. So we can write 7429 as 17 into 19 into 23. Got all these answers? Going to the second question. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. So first one, it is 26 and 91. So 26 can be written as, how we can factorize it? 2 into 13, right? Then what about 91? 1, 7, 21, 3. 7 into 13. So what is the HCF and what is the LCM of these two numbers? HCF of 26 and 91, that is the lowest power. Common factor is 13 and its lowest power is 13 itself. 13 raised to 1, that is 13 itself. And what about the LCM of 26 and 91, which is equal to 2 into 7 into 13, right? That is 14 into 13. So what is 14 into 13? 12, remainder 1, 134, 1411, 281, 182. Now we have to check whether this is equation 1, this is equation 2, whether equation 1 and 2, when we multiply equations 1 and 2, whether we will get the same answer as 26 into 91. Okay. So 182 into 13. What is the answer? 182 into 13. 6, 24, 2, 5, 2, 8, 1, 6, 6, 13, 2. 2, 3, 6, 6. Right? So when we multiply equation 1 and 2, we will get 2, 3, 6, 6. And when we multiply these two numbers, 26 into 91. 26 into 91, what is the answer? 6, 6, 3, 2. Yes, 2, 3, 6. That means LCM of two numbers into HCF of two numbers is same as the product of the two numbers. So we got the answer as 2, 3, 6. Going to the next question. Second one, right? That is 510 and 92. 92 can be written like the factors as 2, 6, 2, 23. Yeah, that is 2 square into 23. Then what about 510? 510 can be written as 3, 5, 5, 7, right? So 2 into 3 into 5 into 17. So what is the HCF and what is the LCM of these two numbers? LCM of 92 and 510, it is the common factor is 2 and 2 only, and its lowest power is 2 itself, 2 raised to 1, that is 2. And what no, that is HCF. Okay, sorry, this is its HCF. And what about the LCM of 92 and 510? LCM, it is common factors 2. Take all the numbers and take the highest power. Among 2 it is 2 square is highest. 2 square into only 1 3 is there, only 1 5 is there, only 1 17 and only 1 23 is there. So 4 into 3, 12 into 5, 60. 60 into 17 into 23, right? What is the answer? See, 23 into 17. 16, 1 3, 1 2, 1 9, 3, right? So again that into 6. 2 3 4 6 0. What about LCM into HCF? That is 2 3 4 6 0 into HCF is 2, right? 0 12 9 6 4 4 6 9 2 0, same, right? So HCF of this into LCM of these two numbers is same as product of these two numbers, that is 92 and 510, and the answer is 46920. Now the third one, 336 and 54, right? Third question, it is 54 and 336. What about 54? What are the factors? 3933, that is 2 into 3 cube. And what about 336? The factors are 21 3 7. So we can write 1 2 3 4 4 times 2. So that is 2 raised to 4 into 3 into 7. And what about the HCF of these two numbers, 54 and 336? Take the common factor 2 and its lowest degree, that is 2 raised to 1 into 3. Its lowest common factor degree, it is lowest degree is 1 in not 7. HCF means take the common factors and their lowest degree. So the HCF is 6. And what about LCM? LCM of 54 and 336. What is LCM? 2 raised to 4 into 3 cube into 7. So 16 into 27 into 7, right? We got the LCM as 16 into 27 into 7. So what is 27 into 7? 49 4, 18, 189 into 16, 54 5, 48 plus 5, it is 53, again 5, 1 6 11, 1 9 1 8 1 1. So 4 12 1, 10 1, 3 3 0 2 4. Now we can check 3 0 2 4 into 6, that is LCM into HCF is same as the product of these two numbers, that is 336 and 54. 24 2, 12 14 1, 12 13, 33, 18 1, 16, 4 4, 11, 8 1. Yes, both LHS and RHS are equal, hence verified. So got these three solutions. Going to the third one, find the LCM and HCF of the following integers by applying prime factorization method, right? So the first one is 12, 15 and 21, right? So how we can write 12? 2 into 3, right? That is equal to 2 square into 3. And what about 15? 3 into 5, right? And what about 21? 3 into 7. So what is the LCM of 12, 15 and 21? LCM is equal to 2 square into 3, 3 into 5 and 3 into 7. So 2 square into 3 into 5 into 7. What is the answer? 4 3 is 12 into 5, 60 into 7, it is 420, right? And what about HCF of these three numbers 12, 15 and 21? Common factor, it is 3 only, right? And its lowest degree is 3 as well, 3 raised to 1, that is 3. Got it? 420 and 3. And what about the next one? 17, 23 and 29. See, what is the speciality of these three numbers? These three are prime numbers. That means they have only two factors, 1 and itself. So 17 can be written as 1 into 17. 23 can be written as 1 into 23. 29 can be written as 1 into 29. Why? Because these three numbers are prime numbers, right? So we can get HCF. HCF of 17, 23 and 29 is the only common factor, it is 1 and its degree is also 1. So HCF is 1. And what about the LCM of 17, 23 and 29, which is equal to 17 into, we have to multiply this 17 into 23 into 29, which is equal to, what is the answer? 29 into 23, what is the answer? 27 to 8, 18, 1, 5, 7, 16, 6 into 17, right? So 49, 4, 46, 4, 42, 46, then 1, 7, 1, 6, 1, 6, 9, 13, 13, 11, 11,339 is the LCM of these three numbers, 17, 23 and 29. And what about the next one, 8, 9 and 25? How we can write 8? 2 into 2 into 2, right? Which can be written as 2 cube. And what about 9? 3 into 3, which is equal to 3 square. And what about 25? 5 into 5, which is equal to 5 square. Now, what is the HCF of 8, 9 and 25? Is there any common factor? No, right? Only 1. We can write it as into 1. That means into 1, into 1, into 1. So HCF is 1. And what about LCM of 8, 9 and 25? Just multiply all these, right? That is 2 cube. That is 8 into 3 square. It is 9 into 5 square, 25. What is the answer? 72 into 25. What is the answer? 36, 4, 14, 0, 1800. So 1800 is the LCM and HCF is 1 in case of 8, 9 and 25. Next question. Given that HCF of 306 and 657 is equal to 9, find LCM of 306 and 657. We know the equation. Which equation? HCF of 306, 657 into LCM of 306, 657 is equal to product of these two numbers, that is 306 into 657, right? And here we know the HCF was 9. 9 into LCM of 306 and 657 is equal to product of these numbers, 306 into 657. And from here we will get LCM of 306 into 657. That is the question, right? So LCM of 306, 657 is equal to the product of these numbers by its HCF. HCF is 9, right? So 9 on 306. 306 is divisible by 9, right? So 3 are 27, 36, 9, 4. So that means the answer is 657 into 34. What is the answer? 28 remainder to 22. Again 2 remainder, 26, 21 remainder to 15, 17, 1, 18, 19, right? 8, 3, 13, 12, 2. So the answer is 22,338 or 22,338. Going to the next question. Check whether 6 raised to n. We have done an example with 4 raised to n, I think, right? So here it is 6 raised to n. Can end with the digit 0 for any natural number n. The same method. That is, if the number or numbers 6 raised to n were to end with digit 0. If it is to be end with digit 0, then it should be divisible by 5. It should be divisible by 5, right? If it is to be end with the digit 0, it should be divisible by 5. This is not possible. Why? This is not possible because why? The prime factors of 6 are 2 and 3, right? Since 6 can be written as 2 into 3. This does not contain the prime 5. It only contains the prime numbers 2 and 3. So, what is that word? That statement? The uniqueness. Remember? So, the uniqueness of the fundamental, this is your scoring section, this sentence, okay? So, the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes except 2 and 3 in the prime factorization of 6 raised to n. So this is important. The uniqueness of the fundamental theorem of arithmetic guarantees that, okay, there are no other primes except 2 and 3 in the prime factorization of 6 raised to n. Therefore, 6 raised to n cannot end with the digit 0 for any natural number n, right? Hence proved. It is not to verify, this is to check. So up to this much. And here you have to write 6 raised to n for any natural number n. Okay? Where n is any natural number or for any natural number n. Okay? Understood? So, if the number 6 raised to n for any natural number n were to end with digit 0, it should be divisible by 5. But this is not possible. Why? Because the prime factors of 6 are 2 and 3. It does not contain the prime 5. It contains only the primes 2 and 3. So, the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes except 2 and 3 in the prime factorization of 6 raised to n. So, therefore, 6 raised to n cannot end with the digit 0 for any natural number n. That's all. Now, the second last question is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Why they are composite numbers? Because 7 into 11 into 13 plus 13, here we can take 13 as common, right? So, what will be the answer? 7 into 11 into, here 13 we have taken outside, plus here 13, 1, because we have taken 13 outside, right? So 7 into 11 plus 1, right? Into 1 plus 1, okay? And here, what is the answer? 13 into 11 into 7, 77. 77 plus 1, it is 78. And 13 into this 78, it is not a prime number. It can be written like this, right? 2 into 3 into 13. Understood? That means this number contains more than 2 factors. What is a composite number? A composite number is a number which is having more than 2 factors, and here this contains more than 2 factors. That means which is equal to 2 into 3 into 13 square. This contains more than 2 factors since the number contains more than 2 factors. This, that is 7 into 11 into 13 plus 13 is a composite number, right? Now, The next one. What is the next one? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here we can take which number as the common one? 5, right? Here also 5, here also 5. So 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1, right? What is the answer? 5 into, here it is 6 4s are 24. So 7 into 24 into 6 plus 1. So what is the answer? 42 into 24. 4 2s are 8, 16, 2 2s are 4, 8, 8, 10, 1008 plus 1. The answer is 5 into 1009 into 1. 1 means, which is a factor of this one also. Into 1 means it's a silent. Here also we can write it as into 1. Okay. Here we can write it as into 1. Here also this is a composite number because it contains more than 2 factors. Other than 5 and 1, there is another number also. Since it contains more than 2 factors, it is called a composite number. Since the same thing, it contains more than 2 factors. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Got it? Got the answers? The final question of this exercise is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. For the same minutes, Ravi takes 12 minutes to drive one round of the field. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So it is given that they start at the same point, same time and are going in the same direction. Okay. And to drive one round of the field, Sonia takes 18 minutes while Ravi takes only 12 minutes. So the question is, they meet again at the starting point after how many minutes? So in order to find the minimum time they will meet at the starting point is to find the LCM of these two numbers. The minimum time they meet again at the starting point is nothing but the LCM of 18 minutes and 12 minutes, right? How to find the LCM of 18 and 12? First we have to find the factors of 12 and 18. What are the factors of 12 and 18? 12 it is 2 into 2 into 3. That is 2 square into 3. And what about 18? 18, how we can write it as 2 into 3 into 3, right? Which can be written as 2 into 3 square. So, what is the LCM of 12 and 18? Which is equal to, what are the numbers? 2, 1, 3 and their highest power. Highest power of 2 is 2 square and the highest power of 3 is 3 square. That is 4 into 9, which is equal to 36. So, after 36 minutes, they will meet again at the starting point. Or we can write, therefore, they will meet again at the starting point. They will meet again at the starting point after how many minutes? After 36 minutes. So 36 minutes is the answer. So hope you all got the correct solutions. So friends, that's all for today's video. We can see the next video with the very next topic, that is revisiting irrational numbers. If you find the channel useful, do support the channel by subscribing and sharing it with your friends who are preparing for class 10 board exam. So see you in the next class. Till then, have a good day and thank you.